Okay. Number 3, you got a series of quadratic equations. You're going to solve them. You're going to estimate the square roots that occur. Okay. Haven't seen anybody really having trouble estimating the square roots. We'll talk about that a little. Let's see. Let's just go to, we have ax squared plus variable c, x minus variable b, and those variables take the values according to the letters in your name. For me, it would be 5x squared plus 6x minus 4. And I didn't put equals 0 on these things, and I should have. Okay? Wrote the equations. I was busy figuring out where the variables go and didn't put equals 0 on them. Didn't see that. But that's what you do. So if that was a source of confusion, you and I understand that, because you said solve these equations and they weren't equations. But it should be pretty clear what you do. Most people seem to interpret it that way. Okay, so, well, you get A equals 5, B equals 6, C equals -4. So zeros are at x equals -b, which is -6, plus or minus square root of b squared, which is 6 squared minus 4ac, be 4 times 5 times -4, all over 2 times 5. And everybody, I think, is okay with the quadratic formula as long as you make sure you know it when you come to the test. Okay, so that's -6 plus or minus. Now, that's 36, and 4 times 4 is 16, times 5 is 80, so that's going to give you 116. Okay? If I did my arithmetic right, and if I didn't, still, you can fix that. Okay. So right there we have it. Now you got that square root of 116. So, how are you going to estimate the square root of 116? You think it's more than 100? What's 100 squared? 10,000? 116 bigger than 10,000? No, 116 is not bigger than 10,000. So the square root of 116 is less than 100. Okay, now can we restrict it a little more?
Between 10 and 11.
Between 10 and 11. If you don't know the squares of the numbers, up to at least 14, which gives you a square of 200, now 196. Okay? You need to know those. And if you don't know them, you can take the time to multiply them out and write them. You're not going to have a calculator. But, you should know the squares. Okay? Be numerically literate. And so knowing that 116 is between 10 squared, which is 100, and 11 squared, which is 121, okay? Between 10 and 11. Okay? That's really pretty easy. If you think to maybe write down the squares that are in the vicinity of 116, right? Okay? So, closer to 10 or closer to 11?
Closer to 11.
Well, 116 is closer to 121 than it is 100, right? How much closer? What do you think it is? 10 point what?
7.
I'd go 10.7. Okay? If you went 10.6 or 10.8, or if you even wrote down your reasoning and then really screwed up your decimal, I'd say, okay, yeah, should have been closer. I'll complain a little bit, I probably won't penalize it. okay? But try to do a decent estimate, okay? Get it between the right two integers, and I'm kind of okay with it, okay? So, okay, so now, put a question mark on that. But probably no more than off by 1/10 at that estimate. If anything, it might be 10.8. I kind of like 10.7 myself. Okay. So. Well, that's 16.7 over 10. That'd give you 1.67. What am I doing? This is negative 1.67. That's totally wrong. 6 minus is 4.7 over 10, so it's 0.47. 0.47 or negative 1.67. And if you did this in your calculator, there's a very good chance those would even be correct, two significant figures. It's not that hard to estimate square roots in little number sense. Okay? So there's your estimate. Now, that's all I ask you to do in this problem. But I said also know how to now use what you know to graph the thing. Okay? You know, it's a parabola. And that one's negative this one. Negative 1.67. Okay. Well, axis of symmetry. Negative 6 over 10, negative 0.6. Y-intercept is negative 4. Let's plug in 0, right? Okay. Plug in 0.6. 0.6 squared is 36 times 3.36 times 5 is 1.8 minus 3.6 minus 4 equals negative 5.6. Again, I did that quick, did it in my head, so don't trust it. Trust but verify. But let's see if it makes sense. Okay, so this gives us a graph. We have negative 1.67. We have 0.47. Where's the y-axis going to go? It goes at 0. 0 closer to 0.47 or negative 1.67. You can always do a scale. You put -2, -1, 0, 1, 2, which kind of spans these numbers. Okay, of course those are the same numbers we use for a lot of the basic functions, right? And you don't automatically use the numbers for the basic functions. You use numbers that make sense in terms of where your zeros are. Okay? If you've got zeros at -7 and 3, you don't set up your scale from -2 to 2, right? Okay? So use a little sense, but in this case, you could have done that and located these, and then you know where the y-axis is, but, you know, 0.47 is a lot less than 1.67. The y-axis is going to go in between these. It's going to be a lot closer to 0.47, but not super close, okay? And 0.47 is a little more than 1/3, or a little less than 1/3 of 1.67, so it's about 3 times as close to this as this. If you do that, you'll have a reasonable graph. Then you can say, okay, here's -4. -0.6 is going to be halfway between these. That's going to be your axis of symmetry. And your y-intercept is going to be at -5.6. So there's your vertex. So you're going to go through this point, and this point, and this point. And you're going to come around here and go through this, and there's a pretty good parabola. Okay? That's something we did well before the first test. Okay? It's a process you should be very good at. Okay? And I'm going to grade it more strictly than I did in the first test because we had more time to get good at it. So I want to see all that. I want to see you explain it all. Okay? I don't want to just see a bunch of undocumented numbers on the test. I want to be able to read your problem without having to go back and read what the problem said. Even though when I grade it, I'll know, you know, after I do a few of these. Okay? Yeah. So, show me what you're doing. Okay?